All right, let's do this. Thanks. Hello everyone, it's October 7th. A very important day. All right, let's see what we have today. Minimum number of swaps to make the string balanced. You're given a zero-index string of even length. String consists of exactly n divided by 2 open brackets and closing brackets. A string is called balanced if and only if it is the empty string, or it can be written as AB, where both A and B are balanced strings. It can be written as this and yes, okay? You may swap the brackets at any two indices any number of times. Return the minimum number of swaps to make S balanced. Yes, the first example. The second example is 0 and 4. 0, 1, 2, 3, 4. Huh. Okay. Wow. So I need to swap to make them balanced. So the end result has to be balanced. And can we say that whatever is already balanced, we shall keep it balanced? Yeah, because if we change something such that the original balanced one is no longer balanced, then that's only going to make things worse, right? Okay, so maybe we can do a DP on this, maybe. I don't know, DP? Let's say DPI is the minimum swap, right? It says minimum swaps to balance. Yeah, I'm not sure from I towards the end. I'm not sure about this. It's like, it's not going to be balanced in this part, so we can only do, yeah, like if it's here, then you have to do one swap, right? And if it's here, what do you do? Right? You don't know what to do. And it's here. No, I don't really think so. Okay, so maybe there's another way to think about it. Because eventually it's gonna be balanced, which means every left we can find, yeah, just every left bracket can find the right bracket, right? Which means if you go, let's say it's a stack, then whenever you hit something that's bad, then it has to be changed, right? It has to be changed. But pay attention that in this case, I can say, okay, I push in this, so I know it has to change. So we're gonna have to swap once, right? Now it's gonna be here, right? We have to say we have one swap, and then this, and then this, and then we pop out, and then it's coming in, and that's it, right? But I have one swap, so I say, okay, this one I can swap. But what if I have something like this? Right, we don't swap it. Alright, let's try the second one. So I have this. I say, okay, I'll swap it. So I have one swap. And then I have this. Okay, that's good. Then I have this. I say, I'll swap. Then I have this. Then I have... So I now have two swaps. Alright. Yeah, I have two swaps and I haven't swapped anything. So at the end, we just see if two swaps. Oh, it will definitely work, right? Because I have even number. Yeah, I have, okay, hear me out. We have even number of left brackets and right bracket, right? And if every time we hit a right bracket without a left bracket, that is a swap. And it doesn't matter because it's the same number, so there will be a left bracket that's unmatched and we need to be swapped as well. So basically this question is, we will do stack, and every time we hit a right bracket that cannot be matched immediately, that is a swap. And every time we hit a good one, we'll pop it. Right? And then we just go through the whole thing and then, okay, let's give this a shot. So we do a stack of character. Right? And we say if stack is empty. So if stack is not empty, right? Stack is not empty, and stack dot peak is equal to a right bracket, no, a left bracket, right? Hold on. It depends on, okay, let's do this. If C is equal to a left bracket, right, and then no matter what, stack dot add C, right? Doesn't matter, we always have to add. Else else if stack is empty, right? Stack here, so it's a right bracket and the stack is empty, then I say rest plus plus and then stack dot add a left bracket, right? Swap. Else, this is currently it's a right bracket and the stack is not empty, right? Stack is not empty, then it definitely has. Then we just do stack dot pop, right? Top of stack must be a left bracket, right? We just do that and at the end we'll return rest. (1963) Use stack. Each time a right bracket is encountered, when the stack is empty, that right bracket must be swapped. a left bracket goes to the stack by default, and a matching pair, that is left bracket on top of stack and a right bracket as current character, would pop the stack. Okay, let's run this. Give it a shot. Get the shot. Your shot. Da, 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 da. Oh, I cannot do that because it has to be balanced. Alright, I just submit it. I feel like it's right. We'll see. And it is right, but it takes a long time. Alright, see if it's possible to make it faster. How would you propose to make it faster? Well, we'll make it faster by not using a stack. Maybe we can just use a, I don't know, yeah, I think we probably don't need to use a stack. Yeah, because the top of the stack is always going to be left. So when I hit a right, we keep the stack size, right? We hit the right, we add, and now we hit the right, we decrement, and now we hit the right, we add. Yep. So this is solution 1. We have solution 2. Same idea as solution 1, but without actually setting up the stack. We only need, since left bracket is the only element possible in the stack, we just need to track the size of the stack to know if it is empty. So we don't need this, we can say stack size. Alright, so if this, then we say stack size plus plus. If this, stack size plus plus. If this, stack size minus minus. And here is, if the stack size is equal to 0, and then we return rest, right? You were shocked and Yep, there we go. That is the solution. Okay, so this one is done. I actually like this one. All right, we go back to this. Yeah, it took so long, so I'm gonna read the hint. So what is the hint? Let's see. Store two sorted lists of intervals. One list will be all times that are at least single booked, and the other list will be all times that are definitely double booked. If none of the double bookings conflict, then the booking will succeed. And you should update your single and the double bookings accordingly. We have two. Yeah, because I was trying this, and man, this is just so complicated to analyze. I don't want to do the analysis anymore. All right, because you have to keep track. Like sometimes it's in the front, it's the back, it's the middle. Hold on. Let me check. What was it's this one, right? Yeah. So I say I'll dry run it. This is not. So we dry run it, right? So if it's in between, then we update. And we go through everything again. And I say if your K is in between, then you have to go up. And then this is the difficult part. I say if start is smaller than the first key, or start is larger than that, then the start is 1. Else if the start is inside, and if it's not, okay, I think so far so good, right? It's inside, and it contains start. It doesn't contain start. Now I find it before, and then we shall put start. This dot line sweep dot get before plus 1, right? That's, yeah. But if it contains, we already done, right? So that's for start. Now we're gonna say for end, right? Now I'm gonna say for end. So if end is smaller than first key, because if n is equal to first key, that doesn't really, yeah, you just don't change. So if n is smaller than first key, you put it to 0. If n is larger than last key, you also put it to 0. That is not true. That is not true. That is not true. No, I think for end, yeah, for end it shall be, no matter what, it's, so we're gonna say this dot, line sweep, it depends, right? If the end is already in there, then what do we do? No, I think it's just the floor key and then the floor key minus 1. I think yeah, it's just floor key minus 1. So what if it contains? So if it does not contain, All right, let's take a shot. Stop bothering me. If it fails, then we're not gonna do this. All right, if this one fails, then that's it. Or we'll try the solution in the, what is this? No such element exception. Maybe because it's empty. Oh, okay. Let's say this line sweep is empty. Nope. Still not right. Yeah, this doesn't work. All right, we take a look at this. So we have two sorted lists of intervals. Okay, one is single booked. Yep, one is single booked. Okay, so I think what it's trying to say is we can do something like this. Use this example, right? So we say single booked is here. 10, 20, right? 50 comes in. It does not have any overlap, right? We do have to check the overlap. No overlap, 50, 60. Next one, 10 and 40. 10 and 40 we have overlap. So we figure out which part is overlap. So we can say we have a double booked is here, which is 10 to 20 is double. But then 20, so this one has to be removed, right? And then it's gonna be 20 to 40. And then now 515 comes in. So 515 we check for singly booked 515, which is not booked. Well, we should first check the double booked. 515. How do you check? You find something that's, yeah, you find a star that's bigger. So it's the ceiling key, right? You find the ceiling key. And then if it's in between you, and then that's booked. So 515 is wrong. You cannot do that. Next one, 510. So 510, we try the double booked. Nothing is double booked. So that's fine. So we go to the single booked. And I go to single booked 510. Then we try to find something that's bigger than 5, right? So a ceiling. And ceiling 20 is even bigger than your current 10. So that's a single book. So we have 5 and 10. Next, 25 and 55. So 25, 55 comes in. 25, 55 is no double book. Now we go to single book. 25, 55. So something bigger than 25, which is 50. Right? Which is 50. Because 50 is the current bigger. So yeah, we need to find both, like 20 and 50. So we need to find both, the smaller and bigger one. So start from 20. 20 is to 40, okay? And 40 is in between. So we have double booking, which we need to pick. So 25 to 40 is double booking, right? 25 to 40 is double booking. And this has to be, single booking will be to 25, all right? And then 40 to 55. 40 to 55. Oh, basically we call it again. 40 to 50. Oh, wait. Wait a minute. No, it's fine. Because if initially you have double book, you will already find it. So this is fine. So 40, 55. Huh. Okay, so what you say is give me an interval. I'll find the one smaller than it. Right? And if there's one smaller than it, from the I need to find both. Smaller and bigger than it. Right? And then smaller than it and bigger than it. And then the thing is, right, when you start doing it, yeah, you find one smaller and one bigger. And then depends. So you know you here, right? Smaller and then bigger because there's single book like that. And then when you are inside, you can be in different positions. And then if you're in here, then you basically do it one more time, right? If you're in the first round, then 40 is double booking, right? You have double booking, and then you start from 40 again. You start from 40, and then 40, and then the next. And then next is 50. And yeah, because it's something bigger, right? So now we need to consider the end. Ugh. Feels like I'd rather. This is fine. This. Yeah, we have this. That's good. This, that's good. And then this situation, we'll say. Depends, right? If it's big, then we will do this and then we'll call it again. Right, then we'll have some double booking and then we'll just get a new one. Okay, that might work. But I feel, because the solution I submitted, this is really simple. Right, this feels really simple. Yeah, I think at this point, because I have an idea, but it just feels difficult. It feels complicated, and I am using. Are you sorting it every single time? Holy crap! You're not even sorting it. Overlapped interval, line sweep. Okay, I think I should just read it at this point. All right, we'll read it. We'll read it some other time. Yeah, I'm not doing it. This is hard. This is very hard. I put in nightmare already because I can solve it. Anyway, I will see you guys tomorrow. Adios.